so that when we start comparing our fractions and decimals and percents, we'll know how to handle these types of problems. So we're in 6th grade, no more remainders. I'm going to give you a couple examples. Copy your notes down as I go. Let's take a look at real simple division, 26 divided by 5. So knowing divisibility rules, we know 5 will not go into 26 evenly. We're going to have a remainder. Let's see what we're going to do with our remainder. 5 goes into 26 5 times. 5 times 5 is 25. Subtract. There's our remainder of 1. Now we no longer in 6th grade want to say 5R1, 5 remainder 1. We want to turn that fraction remainder, or we want to turn that remainder into a fraction. So I'm going to put my remainder up here as my numerator. And I'm going to use my divisor, which is this 5, as my denominator. So with the remainder of 1, it now becomes 5 1/5. Let's write down a couple steps how to do this so you remember later. Number 1, you divide like you normally do. Number 2, your remainder becomes that top number in a fraction is called the numerator. So your remainder becomes the numerator, and let's see, the denominator, where does that come from? The denominator is actually we have to remember our vocabulary. That's called the divisor. So our denominator is the divisor. And that's it. Sometimes we may need to simplify. In this case, we don't. All right, fraction remainder. Let's look at decimal remainder. Same method. Take your 26 and divide it by 5. 5 goes into 26 5 times. 5 times 5 is 25. Subtract and you get 1. Now instead of a fraction remainder, I want to make it a decimal remainder. How do I do that when I don't see a decimal? Well, I could put a decimal right behind the 26 and add a 0. That does not change the value of 26. 26 is equal to 26.0. They're the same exact thing. All right, now I have another number I can bring down. So I'm going to bring down the 0. Now I'm going to have 5 go into 10 2 times. Oops, I forgot something up there. That decimal I added here, I want to bring it straight up. So it's 5.2, not 52. All right, so 5 goes into 10 2 times. 5 times 2 is 10. Subtract. There is my 0 remainder. So what were the steps here? Number 1, divide, like we just did. Number 2, if you see a remainder, add a decimal. And it's called annexing zeros. Annex zeros to the, what's that number called? Inside this. That's called the dividend. It's important to know your math vocabulary. So add a decimal and annex zeros to the dividend. All right, looks pretty easy. Let's take a look at what might happen with some numbers, so we're prepared for these. What if I can't get rid of the remainders using decimals? Well, let's see what that's called. That's a certain kind of decimal when you have numbers that you just can't get rid of the remainder. So let's try 10 divided by 3 with a decimal remainder. And let's see what's going to happen. All right, 3 goes into 10 3 times. 3 times 3 is 9. Subtract and you get 1. Let's get rid of that remainder using a decimal. So add your decimal point and a 0. Bring the decimal point straight up and bring down that 0. 3 goes into 10. Again, 3 times. 3 times 3 is 9. Subtract and you get 1. I want to get rid of that 1. I'm going to annex another 0. Bring it down. 3 goes into 10 3 times. 3 times 3 is 9. Subtract. Uh-oh. I see a pattern. The same thing's going to keep happening and happening and happening. This 3 is repeating. It's going to go on and on and on, never ending. So that's called a repeating decimal. Now in math, we have a notation for that. That would actually be 3.3 with a bar over the 3. That tells us that 3 is a repeating digit. Okay, let's take a look at another one where it repeats. And this is going to repeat a little bit differently, so pay attention to this one. 22 divided by 7. And since I already know that they're going to repeat, I'm going to go ahead and right away add my decimal. I'm going to add like a few zeros because I have a feeling this one's going to go on for a while. Okay, so 7 goes into 22 3 times. Make sure your 3 is right above that second 2. 7 times 3 is 21. Subtract, and you get 1. All right, to get rid of that remainder, I bring down that 0 I annexed. 7 goes into 10 1 time. 7 times 1 is 7. Subtract, you get 3. Get rid of that remainder. Bring down that 0. 7 goes into 34 times. 7 times 4 is 28. Subtract, and you get 2. Got to get rid of that 2. Bring down another 0. 7 goes into 22 times. 7 times 2 is 14. I'm going to start running out of room. 6 is my remainder. I could add another 0 and bring it down and try to get rid of 60. I'm going to just tell you, this pattern, there's no pattern, but they will go on and on and on and on, these numbers. Okay, so this is a repeating decimal, but since there's no pattern, we call this an irrational number. It's not rational, it's irrational. Irrational. The pattern won't repeat, but digits will just keep going and going and going. So these few things might happen as you are working on the next few problems. So I'm going to give you some problems to practice, and you can bring them back to class tomorrow. So number 1, I want to see a fraction remainder, 42 divided by 10. I want to see a decimal remainder, and I want you to show me if they're equivalent or not. Prove it. How do you know the answers are the same? Number 2, 37 divided by 4. Number 3, 15 divided by 4. Flip your paper over. Number 4, 77 divided by 5. And number 6, 128 divided by 3. Well, that shouldn't be number 6. That should be number 5. Thanks for noticing. All right, come back with your answers, and we'll talk about it in class tomorrow. Have a great night.